If you're a C++ developer, you know the goal is always to build reliable, solid code. So today, we're going to dive into a practice that's absolutely crucial for that: unit testing. We'll look at how to build way more robust code, starting from the smallest pieces. It's a question that probably keeps a lot of us up at night. You've written hundreds, maybe thousands of lines. It compiles just fine, it seems to run, but is it really doing what you think it's doing in every single edge case? Are there some sneaky bugs just waiting to pop up at the worst possible moment? Well, the best way to get confident in your code isn't by trying to test the whole giant machine all at once. Nope. The trick is to start small. You want to make sure every single little gear and cog is perfect before you put it all together. And that's the core idea we're going to unpack today. Oh man, we have all been there. Your app is just not working right, but the error is totally vague, or even worse, there's no error at all, just the wrong result. And there you are, staring at this huge mountain of code, trying to pinpoint that one tiny mistake. And that's really the heart of the problem, right? As our programs get more and more complex, the number of hiding spots for a bug just explodes. A teeny tiny error in one function can set off this crazy chain reaction somewhere else entirely. It makes debugging feel like this impossible game of hide and seek. So, how do we fight back? Well, we use a classic divide and conquer strategy. Instead of trying to find the one faulty room in a giant castle, we make sure every single brick is perfect before we even start building. This whole idea is called bottom-up design. Honestly, this is the best way to think about it. Every single function you write, it's like a Lego brick. Now, before you start building that awesome spaceship, wouldn't you want to know that every single brick is solid and shaped exactly right? Of course you would. And that, right there, is what unit testing is all about. So to put a formal name on it, that's what we're doing. We're taking each of those functions, those units, and we're putting them through their paces, all by themselves. We pull them aside, we feed them some inputs, and we check, did you give me the exact output I expected, yes or no? Simple as that. And this is that bottom-up approach in action. See? You break down the big problem, you build these small, focused functions, and then, and this is the absolute key, you test each one of them on its own. So by the time you actually assemble your final program, you're not just crossing your fingers and hoping it works. You know every single piece is solid. Okay, so where do we get started? Well, luckily, C++ gives us a really basic built-in tool that lets us dip our toes in the water. Now, it's not the most powerful thing in the world, but for a quick check, it's a great first step. Let me introduce you to assert. It's a handy little macro that lives in the cassert header. The idea is super simple. You give it some expression that you believe should always, always be true. If it is true, great, your program just keeps on chugging along. But if it's not, well, that's when things get a little dramatic. And listen, this is the most critical thing to get about assert. It is 100% all or nothing. If that condition you gave it turns out to be false, your program doesn't just print a warning. It stops dead in its tracks. The entire application just halts right then and there. And that brings us to the big trade-off. Halting the program can be useful to catch a major problem during development, but it's awful for actual testing. I mean, think about it. If you have 10 tests and the very first one fails, you never find out about the other 9. It makes assert a pretty poor choice for any kind of serious, comprehensive test suite. Okay, so assert is... way better. We need something that can run all of our tests at once and then just give us a nice report of what passed and what failed. So let's level up and check out a proper framework like doctest. This is where third-party libraries really shine, and doctest is just fantastic. It's so incredibly easy to get going with it. You literally just include one single header file in your project. That's it. No complicated setup, no linking libraries. It's fast, it's modern, and it gives you so much more power than assert. And just look at how easy the switch is. The syntax is super clean and easy to read. What used to be an assert call just becomes a check macro in doctest. It's just as simple to write, but what happens when it fails? Oh, that is a complete game changer. This is the magic right here. When a doctest check fails, it logs the failure, telling you exactly what went wrong and on what line, and then it just keeps going. It moves right on to the next test. This means you can run 100 tests and get a complete report of all 20 that failed, all in one go. And here's a perfect example of the power you get with a real framework. Look, anybody who's worked with floating point numbers knows that trying to compare them with a simple equals sign is just a recipe for disaster because of those tiny little precision errors. Well, doctest has a built-in solution for that, a proxy. It handles that close enough comparison for you, instantly solving what is usually a massive headache. All right, let's bring this all together. We've seen the super basic quick check, and we've seen the powerful flexible framework. Choosing the right tool is really all about understanding the job at hand. It's about building up your confidence so you can write code that you can actually trust. When you boil it all down, this is the difference. For a quick and dirty check while you're in the middle of coding something, assert is totally fine. But for building a real suite of tests, for doing comprehensive unit testing where you want to see all the results and have a ton more flexibility, a framework like doctest is, without a doubt, the winner. So, what's the bottom line? Don't be afraid to throw an assert in there to quickly confirm something while you're working. But when it's time to build a real safety net for your code, to make sure it stays healthy and reliable for the long haul, you need to invest the time in a proper framework. Trust me, it will pay for itself 100 times over. And that's where we'll leave it. You know, unit testing isn't just about squashing bugs. It's about building with confidence. It's about creating software that's dependable from its very foundation. So the real question is, for you, what's the first brick you're going to test?